somewhere on the outskirts of the famous cosmic arm, in a silence that knows no sound but is filled with the movement of light and gravity, there is a system in which two huge stellar currents slowly glide near a larger galactic structure. These formations do not look like the usual spirals with dense nuclei and clear arms. They are stretched, distorted, like a fabric that has been pulled by invisible forces for billions of years. One of them glows with a soft, milky glow, saturated with blue flashes of young stars. Within this flow, matter does not lie still. It is compressed, torn apart, and reassembles into dense clouds where new luminaries are born. This is the region where the gas nebulae do not have time to cool down before gravity begins a new cycle of star system formation. Nearby, there is a second formation, more compact, denser, but no less chaotic. Its structure appears to be torn apart, as if it has already survived a collision or prolonged gravitational stretch. There is less calmness, more tension. The filaments of gas stretch out into long tails. The star clusters shift as if they were under the constant influence of a huge invisible hand. Both structures do not move in space in isolation. They are connected to the larger galactic system, whose gravity controls their trajectories. Their motion is not like the stable orbits of the planets around the stars, but rather a slow fall and flight at the same time, an endless desire to maintain shape which is constantly destroyed by an external force. Inside these clouds, stars form faster than in quiescent galaxies. Young hot stars flare up in dense gaseous regions, and their ultraviolet radiation cuts out voids in the surrounding matter. These voids do not remain empty for long. Shock waves from new supernova explosions compress the gas again, starting the next birth cycle. Here, time does not feel like a line. It manifests itself as a process. Compression, flash, destruction, redistribution of matter. Each region of space within these clouds lives its own dynamics, but they are all connected by a common gravitational fate. On the one hand, these structures look like satellites of a larger galaxy. On the other hand, they are like traces of ancient interaction stretched out in space. Their shapes are constantly changing. Tidal forces pull matter into long arcs, forming bridges of gas and stellar matter that connect different regions of space. There is no emptiness inside these bridges. Rarefied gas moves there, which gradually condenses, forming new centers of star formation. These processes are so large-scale that individual stars do not play a role. Entire waves of birth and decay are important. Radiation from massive stars breaks through the environment, creating regions of ionized gas that glow in specific spectra. These zones become markers of recent events, where supermassive stars have recently appeared and quickly disappeared. Sometimes, catastrophic events occur in these clouds. Supernova explosions tear apart local structures, ejecting matter over vast distances. Shock fronts propagate through gas clouds, changing their shape and density, like waves passing through a dense medium.
And yet, despite the destruction, the system does not disintegrate. Gravity holds everything together, creating a complex, dynamic network of interacting streams of matter. Even elongated structures that extend far into space remain part of a single process. These galactic formations do not exist in isolation. They are surrounded by a rarefied environment, which also contains gas, dust, and traces of ancient interactions. As it moves through this medium, impact regions are formed, where matter is compressed and heated, creating additional zones of activity. Each movement of these systems leaves a trace in space. These traces do not disappear instantly. They persist as structures of gas and stellar streams, which can exist for billions of years, gradually changing shape, but not disappearing completely.
And the longer their dynamics are observed, the clearer it becomes that these are not static objects. This is a process stretched over space epochs. Constant motion, constant change, constant redistribution of matter. Even now, at this point in cosmic time, within these clouds, new stars continue to flare up. Old structures are collapsing, and new streams of matter are forming that will one day change their shape again. And this flow does not stop, because the very nature of these cosmic structures does not allow a state of rest. The matter inside them is constantly redistributed, like a huge invisible mechanism, where every particle of gas and dust participates in endless motion.
Where the density is slightly higher, gravity begins to intensify the compression, and space gradually turns into the cradle of future stars. Where the radiation pressure becomes too strong, the clouds break apart, dispersing into the environment. But even this dispersion does not mean disappearance. It is only a transition to a new state. Inside one of these cosmic clouds, long, elongated structures are particularly noticeable, resembling giant streams of matter stretching for thousands of light years. They are not stable formations, they are traces of gravitational interactions stretched out in time.
These streams may contain young star clusters that have just begun their journey, as well as the remnants of older systems that have already survived supernova explosions and lost their original shape. In some areas, the gas becomes so dense that it begins to collapse at several points at once. This creates a chain reaction of star formation. One burst of birth triggers the next, and so on, until the entire region is filled with bright, hot objects. These stars live fast, bright, and unstable, their radiation forming huge cavities around them, blowing gas away and creating voids that eventually fill up with new material again. Near these active zones are quieter regions where matter has long lost enough density for active star formation. It is dominated by old stars, slowly rotating in their gravitational orbits. Their light is dimmer and more stable, but they form the bulk of these cosmic structures. They are a kind of framework around which all the processes of change continue. But even these calm areas cannot be called immobile. Gravitational waves caused by interaction with the larger galactic system pass through them. These waves slowly change the distribution of matter, creating weak but constant displacements. Over time, such displacements lead to the formation of new dense regions, where star formation can begin again. It is particularly interesting to observe how gas clouds react to shock waves from supernovae. When a massive star completes its life cycle, its explosion ejects a huge amount of energy that spreads through its environment. This front compresses neighboring clouds, heats them up, and at the same time triggers the processes of destruction and creation. In one place, matter disperses. In another, it begins to condense. This duality is the basis for the existence of these cosmic structures. Destruction here is not the opposite of creation, but a part of it. Without destruction, there would be no conditions for a new birth. And without birth, there would be no material for future changes. In the deepest regions of these clouds, dense cores are hidden.
Zones where gravity is so strong that it begins to dominate all other forces. It is there that the most massive stars are formed. Their lives are short by cosmic standards, but they play a key role in the evolution of the entire structure. Their radiation, winds, and subsequent explosions form the surrounding space, as if carving new shapes into it. Sometimes these massive stars exist in close groups, where their interaction increases the instability of the region. Gravitational influences intersect, gas currents collide, and the entire area begins to resemble a bubbling ocean of energy and matter. In such conditions, the existence of stable orbits is impossible. Everything is in constant reconstruction.
And yet, even in this chaos, you can see patterns. The overall shape of these clouds gradually changes under the influence of the external gravity of the larger galaxy. They stretch out, forming long arcs and tails that stretch in space like traces of invisible movement. These structures can exist for billions of years, slowly changing their shape but not disappearing completely. Over time, new dwarf systems can form in these elongated regions. They are born from condensations of matter that are separated from the main flow. These formations become independent but are still connected with the general dynamics of the environment.
Thus, the entire system is a continuous chain of interactions. The birth of stars, their evolution, explosions, the redistribution of matter, the formation of new structures, and the repetition of the cycle over and over again. This is not a static picture, but a process stretched over a scale that cannot be imagined within the framework of one state. And even now, while these words capture only a small part of what is happening, changes continue inside these cosmic clouds. Gas moves, stars flare up, gravity slowly reshapes entire regions, and all of this together creates a dynamic system that never comes to a final state.
If you want, I'll go on and delve even deeper into the structure, dynamics, and hidden processes of the large Magellanic Cloud and the small Magellanic Cloud, adding an increasingly dense and cosmo-documentary style without stopping. In these regions of space, interactions between the two main structures that move near the larger galactic system play a particularly important role. Their motion is not random. It is formed under the influence of a complex gravitational field, which is constantly changing due to the distribution of mass around. Each approach, each distance, each bend of the trajectory leaves a trace in the form of elongated streams of matter, which gradually become part of the general structure of the surrounding space. When gas clouds stretch into long tails, they begin to behave differently than in dense cores. The density drops, the temperature changes, and the conditions for star formation become more localized. Instead of a uniform process, separate nodes of activity arise, points where matter gathers in dense clumps and triggers the birth of new star systems. These nodes may exist independently of each other, but they all remain connected by a common flow dynamic. It is especially important that there is a constant redistribution of energy within these structures. Radiation from young, massive stars penetrates the environment, creating regions of heating and ionization. These regions do not remain stable. They expand, collide with each other, and form complex transition zones where the gas can simultaneously contract and thin out. Under such conditions, an effect arises in which the same region of space can be in different phases of evolution at the same time. Young stars, actively forming protostellar cores and destroyed remnants of ancient supernovae can exist within the same cloud. This creates a multi-layered structure where each layer influences the other, forming a complex feedback system. Over time, some of the matter leaves the main area, stretching out into the surrounding space. These flows can travel great distances while maintaining their connection to the original system. They become a kind of bridges along which matter slowly moves between different regions. Such bridges can last for billions of years, gradually changing their shape under the influence of external forces.
Within denser regions, massive stars continue to form. These objects arise quickly, consume huge amounts of surrounding gas, and then, just as rapidly, complete their life cycles. Their explosions become the most important mechanisms for the redistribution of matter, as they eject heavy elements into space and create shock waves that form new areas of compression. Each such cycle changes the chemical composition of the environment. Gradually, the gas becomes more enriched, which affects future generations of stars. New systems are formed in a different environment, where elements created by previous generations of stellar explosions are present. This creates a continuous evolutionary chain, where each generation of matter influences the next. Even in the most rarefied areas, motion is preserved. Where the density of the gas is minimal, there are traces of ancient streams, weak filaments of matter that are barely distinguishable, but continue to respond to gravitational fields. These filaments can serve as guides for future structures if conditions change again. And all this does not happen separately, but as a single system, where each change is instantly reflected on other levels. Gravity binds everything into one dynamic network, where there are no fixed boundaries, but only transitions between states. Even now, the structure continues to change. Gas moves, stars are born and die. Streams of matter stretch and contract, forming new shapes that will look completely different in millions of years. Above these structures stretches an even more gigantic formation, a flow of matter that goes far beyond the clouds themselves. It stretches through space like a huge river of cold gas, almost invisible in ordinary light. This flow is not an accidental ejection of matter. It formed gradually over huge periods of time when the gravity of the larger galaxy began to pull material from the outer regions of the clouds. This is how one of the longest gas structures in the immediate cosmic environment appeared. Within this flow, matter is unevenly distributed. Somewhere the gas almost disappears, becoming barely distinguishable, and somewhere it collects in dense clumps resembling the rudiments of future structures. These areas are unstable. They can collapse under the influence of external pressure or, conversely, begin a slow contraction if the local gravity is strong enough. The farther the flow moves away from the clouds themselves, the colder and rarefied the matter becomes. The temperature drops, the speed of movement of individual sections changes, and the entire structure begins to look like a giant plume stretched through intergalactic space. But even in this state, the flow remains dynamic. He did not freeze. Within it, turbulent movements, cloud collisions, and a slow redistribution of density continue. In some regions of this flow, traces of shock waves are observed. They appear where gas collides with the environment, or where the remnants of ancient supernovae pass through intergalactic matter. These collisions heat up the gas, causing it to glow briefly in certain emission ranges. Then the energy dissipates, and the flow becomes almost invisible again.
The movement of the Magellanic Clouds themselves is also of great importance. Their speed is so fast that they literally tear through the environment. At the same time, the outer layers of the gas begin to experience pressure. An effect similar to the cosmic wind occurs. Matter breaks off from the edges of galactic structures and is carried back, strengthening the elongated tails. This leads to the fact that the shape of the clouds never remains constant. Some areas lose matter, others receive new portions of gas from internal currents. In some places, the processes of destruction begin to dominate, and in others, the processes of birth. The whole system seems to be balancing between disintegration and preservation of its structure. Inside the large Magellanic Cloud, a giant active region filled with hot gas and young stars stands out. It is one of the most powerful star-forming regions in the near cosmos. There, energy is released so intensely that the environment is literally torn apart by streams of radiation and stellar winds. Huge cavities expand through gas clouds, collide with each other, and form a complex network of luminous structures. Some of these cavities reach such sizes that there is practically no dense gas left inside them, but their boundaries become zones of new compression. There, shock fronts collide with cooler matter, setting the stage for the next generations of stars. This creates a continuous chain of activity capable of sustaining star formation over long cosmic ages. Dense, dark clouds of dust move among these luminous structures. They hide some of the radiation, creating huge shadows inside the galaxy itself. Inside such clouds, the temperature can be extremely low, and the matter can be so dense that light is almost unable to pass through it. It is there that new protostars are often born, surrounded by rotating disks of gas. Sometimes entire clusters of young stars form inside such regions, almost simultaneously. They arise as a result of the collapse of a huge cloud, which broke up into many dense cores. These stars remain bound by common gravity for a long time, forming compact groups moving through the galactic medium. But such stability does not last long. Radiation from massive stars gradually destroys the surrounding cloud. The gas begins to dissipate, and the cluster itself slowly expands. Millions of years later, many of these groups lose their original shape and become part of the overall stellar structure of the galaxy. The small Magellanic Cloud looks different. Its shape is more chaotic, as if it has survived a particularly strong gravitational influence. It has less symmetry, more elongated regions, and more unstable structures. Some regions are literally torn apart by gas flows going into intergalactic space. This gives the impression of a system in a state of continuous deformation. And yet, it's this instability that makes clouds so active. Gravitational interactions constantly stir matter, preventing it from remaining in equilibrium for long. And where there is no equilibrium, new processes appear. Compression, collisions, flashes, the formation of new structures. Even the dark matter surrounding these systems plays a huge role. It cannot be seen directly, but it creates an additional gravitational field that keeps the clouds from completely collapsing. Without this invisible component, many outer regions would have been scattered in space long ago. And as the clouds continue to move around the larger galaxy, their fate gradually becomes more complex. Gravity slowly changes their trajectories. Gas flows are pulled further and further. Some areas lose matter faster than they can replenish it. But at the same time, active zones of new star birth remain inside, as if the clouds themselves are trying to maintain their structure despite the constant pressure of the surrounding space. And yet, even after billions of years of movement, collisions, and loss of matter, the Magellanic Clouds continue to glow in the dark space, maintaining within them a continuous stream of birth and destruction.
Their gas rivers stretch across the intergalactic void. Young stars erupt among the cold nebulae, and gravity slowly changes the shape of these ancient structures. The cosmos around them remains silent, but there is never peace within the clouds themselves. There's an endless evolution of matter, light, and energy going on, a motion that won't stop as long as the galaxies themselves exist.